A very good evening to everyone. I am Sahil Gaurav. Here we are going to discuss today tutorial live session for Big Four. So in the last session we have discussed about the voltage drop and power loss for different types of different feeders in different types of substation. In today's class we are going to discuss about the reliability indices and the problems based on the very popular reliability indices. So before we discuss, go through today's session, just we have a look on the K constant. One of you have asked, I think Rahul Patil, about the physical significance of constant. So as we all know that K is a constant that can be defined as percentage voltage drop per kilovolt ampere mile. And this is the well-known expression for K constant. And its unit is voltage drop per unit per kilovolt ampere mile. So this figure, if you see, this is a K constant for copper conductors, and here assumed as a lagging load power factor of 0.9. And for detailed description about this K constant, you can refer to Turan Gonin book, Electric Power Distribution System Engineering. So here this figure gives about the K constant for various voltages and copper conductor sizes. And this figure is developed for three-phase overhead lines with an equivalent of 37 inch between the conductors. Now if you look upon the figure, in this axis we have copper conductor that is given in AWG or MCM. Basically AWG means American wire gauge and MCM means 1000 circular miles. So American wire gauge, that is generally used in North America side, and the dimension of copper conductors for power and telecommunication purposes they used in AWG. And MCM means they are generally used in Europe side and rest part of the country in Europe. Let us take Germany, and there it is a speak of like 1000 circular miles. So 1000 denotes M, and mils also denote M. So 1000 circular mils. So this side we are given with the conductor size, and this size we are given with the line to line voltage. So as this as we can understood from this figure also, that as we also know from the basic power system engineering, that if this voltage level increases, like here if you see this voltage level going to increase this side, so we can see that this percentage voltage drop per kVA mile, that is nothing but that is K constant. So this is K constant. So this is going to be decreased as the voltage, line to line voltage increases for each type of conductor sizes. So like for a specific type of voltage levels, this is the this is the figure, this is the line. And as we going to decrease, the slope remains as it is. As we going to decrease the line to line voltage, slope remains as it is, but this line just goes down. So that means K constant is also going to be decreased. That is percentage voltage drop per kV mile is also going to decrease. And also if you increase the copper conductor sizes in this side, that means you are going to reduce the losses. Therefore, this percentage voltage drop per kV mile also going to be decreased. So that's why for for a smaller dimension of copper conductor, we are having higher losses, because within a small wire there is a large amount of current flowing. But if you increase the wire dimension, increase the wire size, then the same amount of current will flow through this lane through the wire. That means you are having a lesser value of resistance, and that's why the voltage drop will also reduces. So as the copper conduct cross section area of conductor increases, the K constant decreases for the voltage levels for each voltage levels. So this is the constant for copper conductance for the with the you can say with respective to line voltage and the copper conductor sizes. Now let us come to today's topic. So in today's session we are going to discuss about the reliability indices, and basically in the power distribution system what do you mean by reliability. So reliability is the ability of power delivery system to make continuously available sufficient voltage of satisfactory quality to meet the consumer needs. So the basic definition of reliability is that it means continuity of service to the utility customers. That's it. That means the reliability. And there are several indices by which we can have measure the reliability parameters. And and for several types of interruptions, there are different types of indices. Like for sustained interruptions, we know that sustained interruption happen for a fewer second, means a very shorter interval of time. So these are indices for sustained interruptions: SAIFI, SAIDI, CAIFI, CAIDI, ASAI, ASIDI, CTAIDI, and then we have indices for momentary interruptions. Sorry, I just spoke incorrectly. Sustained interruption means that happen for a longer interval of time, that from few minutes to few hours. And momentary interruption means that happen for a shorter interval of time. So sustained interruption that is for longer duration, and momentary interruption that is for shorter duration of time. And then we are having load energy based indices that includes ENS. ENS means energy not supplied. AENS, average energy not supplied. And then ACCI, average customer curtailment index. So these are several type of reliability indices, and we categorize for different types of interruptions, and just put this reliability indices based on the interruption side. So in today's session, we are going to discuss most of the problems based on the sustained interruptions and the load energy based indices. So that we basically asked in your assignment 5. So that will be very helpful. So before we begin today's session, any doubt till here? Rahul Patil, your doubt clear? You were asking about this K constant last class.
Yes, sir.
Okay. So uh, let us have this expression for different reliability indices that will be helpful in solving problem. So first one is SAIFI, System Average Interruption Frequency Index. So that this is for frequency. So it is total number of customer interruptions. It is the ratio of total number of customer interruptions to the total number of customers served. We will see each notations, that what each notation denotes, and how we can calculate from a table that each notation, what is the value of each notation. And SAIDI means System Average Interruption Duration Index, that is the ratio of customer interruption duration, that is total customer interruption duration to the total number of customers served. And CAIFI means Customer Average Interruption Frequency Index, that is total number of customer interruption to the total number of customer interrupted. And we will see also that what is this difference of total number of customer interrupted and total number of customer interruptions, how we can calculate both these values. And CAIDI means Customer Average Interruption Duration Index, that is ratio of customer interruption duration to the total number of customer interruptions. And if you see, CAIDI is the ratio of SAIDI and SAIFI. So both denominator gets cut, and this becomes numerator of SAIDI will become numerator of CAIDI, and numerator of SAIFI will become denominator of CAIDI. And the next reliability parameter we have average energy not supplied, that is summation of L average I into Ri, where L average I the average load connected to load point I, and Ri the registration time for each interruption event. And then we have average energy not supplied, so we have to take average of energy not supplied. So we have to divide it by total number of customers served. So whatever the energy not supplied to the total number of customers served, that will give you average energy not supplied. And now average customer curtailment index. So that is total number, that is the ratio of total energy not supplied to the total number of customer interrupted. So that is ENS divided by CN. And, and then we have average service availability index, that means customer hours service availability to the customer hour service demand. So whatever the average service duration for the customer. So in this here this expression is given for per year. So generally in the problem they asked for per year. So here this number of hours given in per year 8760. So that is the thing. And next we have ASIDI, average system interruption duration index, that is the ratio of total energy not supplied to the total connected load. So this will give average system interruption duration index. And then we have CTAIDI, customer total average interruption duration index, that is the ratio of total customer interruption durations to the total number of customer interrupted. And this CTAIDI is hybrid of CAIDI and is calculated the same expect that the customer with multiple interruption are counted only once. So if you see all these things, then the most difficult part is that how you remember all these things. So just correlate each terms so that you can easily remember. So here if you see SAIDI and SAIFI, that denotes that interruption statics over the entire customer base, right? This SAIFI, and SAIDI denotes denotes about the system, that denotes interruption statics over the entire customer base. Interruption statics over the entire customer base. That means the system. So that's why if you see in the numerator, we have used the total number of customers served, that is NT. And this is the frequency, and if you see here, this is duration term. So the customer interruption duration you have to multiply with Ri. So Ri the restoration time or repair time you can say for each interruption event. So this will give you duration. So you have to multiply with Ri. Now if you see the C term, like here they have used the C term in CAIFI, and one more term they have used in CTAIDI. So these indices refers to the only customer who experience interruptions like CN. These are with the where C term is used. These are used with the customer with respect to customer like CAIFI and CTAIDI. That means like a customer who experience 3 times in a year, you have to count them only one. So that's why total number of customer interrupted that denotes CN. Means the customer may experience multiple interruption during a year, during a certain interval of time, but you have to count only once because the customer is only one, but the number of interruption may be may be more. So these are with respect to customer base. While this CAIDI is with respect to total number of customer interruptions. So CAIFI and CTAI with respect to CN, that is total number of customer interrupted. And then this CTAID, as I have noted down in the last point, CTAID the hybrid of CAIDI and is calculated the same expect that the customer with multiple interruptions are counted only once. So in CTAI in CAIDI we have denominator sigma ni, that is total number of customer interruptions, while Cn is the total number of customer interrupted. So the basic difference between this is that. So CAIDI is sigma RINI, while CTAID is sigma RINI to the Cn. So you have to see that whatever the respect with respect to here this term customer comes, so it denotes about the customer interruption. While if the term they have comes like system, then this will come as with respect to total number of customers served. So just look upon this expression once more, you will get easily remember and you can use in the exam. And this energy not supplied, it is very easy. You have to just take the whatever the average load connected to load point I, and you have to multiply it by with the time so that you can get energy. So this is very easy. And average energy not supplied, you have to just subtract and just divide by this total number of customers served. And while this average customer curtailment test, so here again this customer term comes. So whenever the customer term comes, then you have to take with respect to Cn, that is total number of customer interrupted. And only in CAIDI it is with respect to total number of customer interruption, that is sigma ni. In CAIDI we have used. While while in SAIFI in CAIFI and in CAIFI CTAIDI and ACCI average customer curtailment index, it is with respect to CN, that is total number of customer interrupted. And the customer may get multiple interruptions, but you have to count each customer only once. I hope this point will help you in remembering this expression. So that's why I discussed about how to remember all the expression. If the system comes, then you have to take with respect to total number of customers served. If the customer term comes, then you have to take with respect to total number of customer interrupted. And only in CAIDI you have to take the total number of customer interruption is irrespective of total number of customer interrupted. We will see the difference between this. What is the total number of customer interrupted and total number of customer interruptions while solving the example. And ENS and AENS are very easy, that you don't need, you can easily remember. And ASI little bit you have to take care. And ASID is it is also with respect to system. If you see average system, then it with respect to total connected load, total energy not supplied, to the total connected load. Still here any doubt? Dharmender, Jaswant, Lekha, Priyadarshini, Rahul Patil, Satish. Some new attendance is today. Till here any doubt? Okay, Priyadarshini, no doubt. Thank you. So we can move forward. So these are the important reliability notations. You have to, we are using these reliability notations like total number of customers served, that is denoted by NT, and then we are having with total number of customers interruptions, that is denoted by sigma NI, and then we are having total number of customers interrupted, that is CN. So in CN, the customer is counted only once regardless of the number of times interrupted. So these two are little bit confusing. So sigma Ni is always greater than Cn, because in sigma Ni, a customer having multiple interruptions, each interruption will be counted individually. While in Cn, if a customer is is facing interruption multiple times, then a customer is counted only once. So that is the difference, sigma Ni and Cn. And then we are having customer interruption durations, that is sigma Ri. You have to multiply with the restoration time or repair time, whatever you can say, with the total number of customer interruptions. And then we are having total connected load, that we denote as LT. Total connected load is LT, and total number of customers served, that is NT. Now let us begin to solve the problem. So this is common data for question 1 to question 10. Now whatever the notations we have used, we will see, we will find all the notations, what are the values of all the notations. So first is the total number of customers served. Total number of customers served, that we denote by NT. So what is the value of NT? Can anyone tell?
7,000 customers.
Yeah, so it is connected to 7,000 customers, so NT will be 7,000. And then we are we can find total number of customer interruption. Total number of customer interruptions, that is sigma Ni. So for different type of faults, these are not the customers getting interrupted. So you have to add all these things. There is nothing like that. So sigma Ni will be 600 plus 840 plus 1200 plus 60 plus 120 plus 240. What is the value of this coming as? Six.
3060.
Yeah, correct. 3060. That is the total number of customer interruptions. Now we can find total number of customers interrupted. That is denoted by Cn. So what is the Cn value?
2000, sir.
Yes. And what is the difference of Cn and Nt? In Nt, the customers are also counted who are not facing any interruption. And in Cn, the customers counted those who are facing interruption. That is the difference. I think it is clear to you. So in Cn, the customer is counted only once regardless of the number of times interrupted. And then we can find the next terminology, that is customer interruption durations. Customer interruption durations, that is sigma RINI. So this is Ri given. So this is Ri given for each type of fault event. So you have to multiply the number of customers interrupted for each fault event and the duration of interruption. So it will give you sigma RINI, that you have to multiply all these for each type of fault event. So 600 into 2 plus 840 into 2.5 plus 1200 into 2 plus 60 into 1 plus 120 into 1.5 plus 240 into zero point 0.5. If you do this calculation, you will get sigma RINI as, so this is 1200 plus 2100 and 2400 plus 60 plus 180 plus 120. So this will give you 6060. And we have one more term, that is total connected load. Just once first just solve all these notations and then you can easily solve the problems. So total connected load equal to LT. So what is the value of LT?
22,000 kilowatt.
Yes, so 22,000 kilowatt. So this is the value of LT. Now whatever we have the expressions and whatever the value we have found, just we will use all these expressions and we will find all the reliability indices. So first is SAIFI. So SAIFI is with respect to overall system. So it is with respect to total number of customers served, and the numerator is the total number of customer interruption. So SAIFI sigma ni divided by nt. Sigma ni, what we have calculated, 3060, 3060, and nt we have calculated as 7000. So this will give you 0.437. So this is the answer. So D is the correct answer here. I just want to tell all of you that just note down all these values so that you can use in the problems. Yeah, Rahul Patil, you are correct. This is the correct answer. Priyadarshini, you are also correct. And then we have SAIDI. SAIDI is System Average Interruption Duration Index. System Average Interruption Duration Index. So SAIDI is sigma summation of sigma RINI to the NT, that is total number of customers served. So what is the value of sigma RINI? We have calculated this one as 6060, and total number of customers served is, that is given in the problem, 7000 customers. So you have to divide it with 7000. So you will get 0.8657. Therefore D is the correct answer. Yes, Lekha, Priyadarshini, both of you are correct. Now next we are having with CAIFI. So CAIFI, we know that is customer average interruption frequency index, and that is the ratio of total number of customer interruptions sigma ni and the total number of customers interrupted. So customer average interruption frequency index means that is the ratio of total number of customer interruptions to the total number of customers interrupted. And in CN, the customer is counted only once regardless of the number of times interrupted. So sigma ni is higher, that will is that gives you 3060, while CN is 2000. So this value will give you 1.53. Therefore C is the correct answer. Yes, Dharmender, Priyadarshini, Jaswant, Rahul Patil, all of you are correct. Lekha. Now the next term we are with CAIDI. So it is duration term. So definitely this RI term will come here, and this is with respect to customer also. So but in CAIDI we have to take with respect to total number of customer interruption. So CAIDI is customer average interruption duration index, and it is the ratio of sigma Ri Ni to sigma Ni, and sigma customer interruption duration we have 6000, and the sigma Ni is 3060. So this will give you 1.98.
Not 6,000, 6,060.
Yes, 6060. Thank you. 6060 divided by 3060. So A is the correct answer. Yes, Lekha Pirdasni, both of you are correct. 1.98. Now we have the next term, energy not supplied, ENS. So here we have to do little bit calculation. And this term is very important for power distribution planning. Energy not supplied. So this is sigma L average I Ri. So whatever the load interrupted, we have to multiply with the duration of interruption, that amount of energy the utility bit not supply. So it is very simple. They no need to, means this terminology you can easily remember. So L average I the average load connected to load point I, and Ri the restoration or fall time for each interruption event. So sigma L average I will be 12,000 into 2 plus 7,000 into 2.5 plus 10,000 into 2 plus 600 into 1 plus 1000 into 1.5 plus 600 into zero point 0.5. So first will give you 2400, and then 17,500 plus 20,600 plus 1500 plus 300. So total will give you 42,300. Therefore A is the correct answer. Energy not supplied. How many of you got the correct answer? Yes, just one, then Priyadashini. Both of you got correct answer. Now the next term, we have to calculate the average energy not supplied. So we have to take the average with respect to total number of customers served. So average energy not supplied, we have to take the average of energy not supplied with respect to total number of customers served, that is NT. Average energy not supplied we have calculated, that comes as 42,300 with respect to total number of customers served. Total number of customers served is 7,000. So this will give you 6.04. I am not using unit anywhere, but you can add the unit also. The unit of this one is kilowatt hour per customer served. So C is the correct answer. Yes, Lekha, Rahul, Patil, Priyadarshini, Jaswant, all of you are correct. And if you want to write the unit of this energy not supplied, that will give you in kilowatt hour. And if you write the unit of CAIDI, the top one, that will come in the terms of 1.98 hour per customer interrupted. And you may write in the terms of minute. So it will give you 118.8 minute per customer interrupted. And for CAIFI, it is 1.53 interruption, that is number of interruption per customer interrupted. And for SAIDI, that will give you in terms of hour 0.8657 hour per customer served. So this will give you in minute 9.51.942 minute per customer served. And for SAIFI, it is 0.437 interruption per customer served. So, so you may use the unit. Now let us come to the problem 7. Problem 7 is that average customer curtailment index. So you have to find ACCI, average customer curtailment index. That is the ratio of energy not supplied to the total number of customers interrupted. So average energy not supplied is to the total number of customers served, while this ACCI is the with respect to total number of customer interrupted. So AENS with respect to total number of customers served, while the average customer curtailment index, that is with respect to the customer interrupted. So ACCI ENS is 42,300 kilowatt hour, and CN we got 2000. So this will give you 21.15 kilowatt hour per customer interrupted. Therefore, A is the correct answer. Yes, 21.15. Jaswant and Lekha Pirdasni, all of you are correct. Now let us see the 8 number problem. You have to determine the ASAI. ASAI, the average service availability index. Average service availability index. So the you have to find the customer hour service availability. So that means you have to multiply with total number of customers served with the number of hours, and then you have to subtract the total number of interruption duration. So you have to subtract then sigma RINI. So average service availability index, in the numerator you have to take the number of hours, customer hours, in that the service is available. For that you have to just multiply with total number of customers served with respect to number of hours. Then you have to subtract the number of hours interrupted, number of interruption duration, and then you have to divide with the customer hour service availability in T into 8760. That is the ideal situation. Means for all the time the power is available to the customer, and then you have to multiply with 100. So total number of customer served is 7000. It should be multiplied with 8760. So amount of that amount of energy is available to the customers minus total number of interruption duration is sigma RINI that we have counted. So it is coming as 6060, and divide it with 7000 into 8760 into 100. So just do the calculation. It will come 6132,000 minus 660 divided by 6132,000 into 100. If you do the simplification, you will get 0.999 into 100%. So it will give you 99.99%. Therefore, B is the correct answer. So let us join with this new link, all of you please, and then we will continue there. Why it is taking time? All of you please join the new meeting link. We are going to close this session. All of you please join the new meeting session. Yes, now we can continue this session. I think a screen is visible to everyone. So we are here. We have found this average service availability index. You have to find the customer hour service availability. How you can find? You can multiply with total number of customers served with number of hours per year, and you have to subtract then number of interruption hour. Then you will get the customer hour service availability. So that's it. That will give you average service availability index. Now, next problem is that you have to find this ASIDI, that is average system interruption duration index. ASIDI, average system interruption duration index. So that is the ratio of total energy not supplied ENS to the total connected load LT. So average system interruption duration index is the ratio of total energy not supplied to the total connected load. Total energy not supplied is L average I into Ri divided by total connected load. So L average I we have computed 42,300 divided by total connected load is 22,000 kilowatt. So 22,000 kilowatt is given total connected load. So in the problem they have given the LT value. So this is LT value and number of customers number of customers served, they are given this 7,000 and this 2,000 is CN. So three terms they are provided in the problem only, that is NT, total number of customers served, total connected load is 22,000 kilowatt, and the customers who experience at least one interruption they have given as 2,000. Now if you compute this, then you will get 1.92 as the answer. Therefore B is the correct answer. Yes, Jaswant, Rahul, both of you are correct. Now last problem for this common data problem. So determine CTAIDI, that is customer total average interruption index. CTAIDI, customer total average interruption index, that is the ratio of customer interruption duration to the total number of customer interrupted, CN. It is the ratio of customer interruption duration to the total number of customer interrupted. So sigma RINI we have computed 6060 and CN is 2000. It will give you 3.03. Therefore D is the correct answer. Yes, Rahul, you are correct. Now this is for common data for question 1 to 10. The same type of problem is repeated for question 11 to 20. So just we will quickly solve, and we will solve in a like 10 to 15 minutes, and then we will end the session. Just it is for just revision. So total number of customer connected, they have provided the NT value, and then this total connected load they have provided this LT value, and then we are given with CN value, customers who experienced at least one interruption. So NT we are given with 5,000. Now we can find the sigma NI, that is total number of customer interruption, that you can total number of customers interruption, you have to just add all these values. number of customer interrupted. So it is 500 plus 700 plus 1000 plus 50 plus 100 plus 200. So it will give you 2550, and CN we are given with 1500. Then we can find the customer interruption duration, that is sigma RINI. So you have to multiply the second and third column. So that will give you 500 into 2 plus 700 into 1.5 plus 1000 into 1 plus 50 into 1 plus 100 into zero point 0.5 plus 200 into zero point 0.5. So customer interruption duration will come as 1000 plus 1050 plus 1000 plus 50 plus 50 plus 100. That will give you 3250. And then last total connected load, it is given as 50,000 kilowatt. Now like the previous, you just keep down all these values. We will solve the reliability indices from question 11 to question 12, 20. NT is 5000, sigma NI is 25,000, 2550, CN is 1500, sigma RINI is 3250, and LT is 15,000 kilowatt. So first term is SAIFI. SAIFI is the ratio of customer interruption to the customer served. So customer interruption is sigma NI to the customer served is NT. So this is 2550 divided by 5000. So this will give you 0.51. D is the correct answer. All of you just match with the options. Now we are given with SAIDI, that is customer interruption duration to the customer served NT. Sigma RINI is 3250 divided by NT. NT is 5000. So it will give you 0.65. So B is the correct answer. And if you want to write that 0.65 kilowatt, sorry, that is hour duration, 0.65 hour customer served, that is 39 minute per customer served. And here is 0.51, that is interruptions per customer served. Now CAIFI is the ratio of customer interruption to the customer interrupted, sigma NI CN. Sigma NI is 2550 divided by 1500. So we will get 1.7. Therefore C is the correct answer, and 1.7 interruptions per customer interrupted. Now moving forward, 14th problem. So next is CAIDI. CAIDI is customer average interruption duration index. It is the ratio of customer interruption duration, sigma RINI, to the total number of customer interruption sigma ni. Customer interruption duration is 3250 and to the ratio of 2550. That is customer interruptions. So it will give you 1.27. So this, since it is duration, so it will units is 1.27 hour per customer interrupted, and in a minute it will give you 76.2 minute customer interrupted. So therefore A is the correct answer. Now moving forward to 15th problem, energy not supplied. That is most easily to remember. Energy not supplied is the total connected load, average total connected load to the restoration time or fault time to into Ri, L average I into Ri. It is the energy not supplied. So we have to multiply second and third column, 1002 plus 5000 into 1.5 plus 6000 into 1 plus 500 into 1 plus 800 into zero point 0.5 plus 500 into zero point 0.5. Just compute all these values. 2000 plus 7500 plus 6000 plus 500 plus 400 plus 250. So adding all this will give you 15,500, and this 500 plus 4 900 plus 250, that will give you 1100. 150 total will give you 16,650 kilowatt hour. Therefore A is the correct answer. Now we have to compute the average energy not supplied. Average energy not supplied with respect to customer served. So energy not supplied to the total number of customers served. So average energy not supplied, we know L average I into Ri to the total number of customers served. L average Ri is 16,650 and NT is 5,000. So this will give you 3.33 kilowatt hour customer served. If you face any doubt or anything, you can tell. See the correct answer. Now question 17. ACCI, that is with respect to CN, that is total number of customer interrupted. ACCI is ENS divided by CN. ENS we have computed, that is 16,650 kilowatt hour, and CN is 1500. So it will give you 11.1 kilowatt hour customer interrupted. Therefore A is the correct answer. Now 18, that is ASAI, that require little bit calculation. So average service availability index, you have to find the average duration of customer hour service availability with respect to the total number of service available, total number of service demand, customer hour service demand. So you have to multiply the number of hours with the total number of customers served, and then the interrupts subtract with the interruption hour, sigma RINI, number of interruption hours, and then divide it to number of customers served with the total duration hour and multiply it to 100%. So in the numerator, the service total number of customers served, and in the denominator, in the numerator, you have to write the customer hour service availability. In that, you have to subtract the customer interruption duration from the from the from the total number of customers served into the number of hours per year. So here, if you compute average service availability index, NT is given as 5000 and multiplied with 8760 minus RINI is 3250 divided by 5000 into 8760. Average service availability index will be 43850 minus 3250. It will give you 43796750 divided by 438 into 100. So it is coming as 99.99% of service availability. Therefore, B is the correct answer. Coming to the question 19, ASIDI, average service interruption duration index. So it is the ratio of energy not supplied to the total connected load. Energy not supplied, we know average load into the interruption hour, duration of interruption hour with respect to total connected load. We have calculated ANS as 16,650 kilowatt hour. Total connected load is 15,000. So it will give you 1.11 hour SAID. Therefore, B is the correct answer. Now moving forward to the last problem, CTAIDI, customer total average interruption duration index. Customer total average interruption duration index, that is ratio of sigma RINI divided with CN. Sigma RINI we have computed 3250 and CN is 1500. So it will give you 2.17 hour per customer interrupted. D is the correct answer. So we have solved 20 problems, basically all based on the, you need to remember the expression, how they are coming, and that will be helpful in your solving the problems. Yes, all of you are Rahul Patil, you are getting correct answer everywhere. Very nice, very good. So any doubt till here? I think today we are able to finish before time. Dharmender, Rahul, just one thing. We are having 3 attendees. Any doubt till here?
No, sir.
So good. Uh, Thank you for attending session. If you don't have any doubt, we can close our session today. Thank you everyone.